Welcome to this video presentation on radiation heat transfer. Today we'll be analyzing example 4, which involves a system of concentric tubes and an electrical wire. Let's look at the problem statement. We have an electric wire with a diameter of 0.25 millimeters and an emissivity of 0.4. This wire is placed within a tube of 5 millimeter diameter with an emissivity of 0.6 and having negligible thickness. This tube, in turn, is placed within a larger tube of 2.5 millimeters diameter with an emissivity of 0.7. We are to assume that the annular spaces between the tubes are completely evacuated, meaning heat transfer occurs only by radiation. If the temperature of the outer tube is maintained at 5 degrees Celsius, our objective is to determine the temperature of the electric wire required to maintain the temperature of the inner tube at 120 degrees Celsius. Now let's begin with the solution by outlining the given parameters. We label the wire as surface 1, the inner tube as surface 2, and the outer tube as surface 3. So diameter of the wire D1 is 0.25 millimeters and its emissivity is 0.4. The diameter of the inner tube D2 is 2.5 millimeters and its emissivity is 0.6. Diameter of the outer tube D3 is 5 millimeters and its emissivity is 0.7. The temperature of the inner tube D2 is 120 degrees Celsius and the temperature of the outer tube D3 is 5 degrees. Now our goal is to find the temperature of the wire T1. Now for a steady state condition, the heat lost by the wire to the inner tube by radiation must be equal to the heat lost by the inner tube to the outer radiation. This implies a constant radiative heat flux through the evacuated annular spaces. And the formula for radiation heat exchange between two concentric cylinders or surfaces where one completely encloses the other is as shown on the screen. So we can also calculate the ratio of the areas for the wire to the inner tube, and also recall that in both cases the V factor F1 to F2 is 1 as the inner surface completely is the outer surface. So for the areas, A1 over A2 equals 0.1 and A2 to A3 is equals to 0.5. Now we equate the two heat transfer expressions and substitute all the known values. And when we do that, we continue with the calculations, and after simplifying the numerical terms and cancelling out the constants like pi and sigma, and the equation gives us a value of 446 degrees Celsius, and that is our answer. This is the temperature the wire must be maintained to keep the inner tube at 120 degrees Celsius. Now this concludes our detailed solution for example 4. Thank you for watching. If you found this video informative, please consider subscribing to our channel for more valuable content. Don't forget to hit the notification bell so you don't miss out on our latest uploads.